Hi friends, hi dear students. After few days, again we meet because of some unavoidable circumstances due to some physical problem. Now I am okay and we are continuing from this like the previous days. And today we are going to learn one important part of the physics that we already learned the first part, current, electricity, and here also today we are going to learn Ohm's law. And this is very important question. Ohm's law, ohmic conductor, non-ohmic conductor, V versus I graph or Ohm's law graph, mathematical forms of Ohm's law, how can you define resistance from Ohm's law? These are very important for the board exam. For the board exam, these are the very important question, and we are going to solve this question like the previous days. So now we are going to start the today's discussion about the Ohm's law. Let us consider a resistance or external resistance through this conductor, the AB, the potential at the A, this is VA, and at the B, this is the VB. And if we consider that VA is greater than VB, then electric current flows through the conductor from A to B, from A to B. Here we give the direction of the electric current from A to B, that is I is the electric current. And when the potential difference increases, then we see that the electric current increases. In very simple electric circuit diagram, like this diagram, another one, here the very simple diagram we use to understand this law, that is the key, and this is the battery. Now here we use the battery, positive terminal, negative terminal, key, and the bulb is connected here. Now the switch is pressed, that is key is on. Now the bulb glows. Now the bulb glows. Electric current flows through this direction to the bulb from the A to the B, from A to B. Here we use the battery, that is 2-volt battery. If we replace this 2-volt battery by another one battery of 3-volt potential difference, then you see that more light will be illuminated by the bulb. That means more electric current flows, as a result the bulb glows better. This shows that when the potential difference increases, the electric current flows through the conductor also increases. Here also other some situation remain constant. So this is the Ohm's law. It states that if the temperature and other physical conditions remain constant, then the electric current flows through the conductor that is directly proportional with the potential difference across the two ends of the conductor. For board exam, this is 2 marks. State Ohm's law, this is 2 marks. When the temperature and other physical conditions remain constant, the electric current flows through a conductor is directly proportional with the potential difference across the two ends of it. In sometimes, in some year, in your question paper, board exam question paper, you see that the write down the mathematical forms of Ohm's law. Write down the mathematical forms of Ohm's law. Mathematical form. Mathematical forms of Ohm's law. Then you have to write. First, you have to draw this. That is the AB is the wire offering resistance R through which I is the electric current flows through the wire. Then, according to Ohm's law, we can write that VA minus VB, that is the potential difference. This is directly proportional with the I. That means we can write this as V proportional I, or V equal, by introducing a constant K, that is K into I. Here K is the proportional constant. K is the proportional constant. Okay. K is the proportional constant, and the nature of this K, let's see here, when the value of I increases or V increases, the value of K decreases. For the constant V, when the value of I increases, the K must be decreases. That means the nature of this constant is such as it opposes the motion of the electron as well as the electric current through the conductor. That is written by V equal R I. So R is the resistance here. R is the resistance. R is called resistance of the material of the wire. R is the resistance. This is K. Now this K is the R. So this is the mathematical forms of Ohm's law. We have to write up to this, then we will get the 2 marks. And you can define this resistance as V by I. So this is the definition of the resistance from the Ohm's law. From Ohm's law, resistance can be defined as this, the ratio, resistance R, this is equal the ratio of the potential difference with the electric current. That is the potential difference, simply written as PD, potential difference divided by electric current. That is equal V by I. So this is for 1 mark, define resistance from Ohm's law. Okay. Next question, do all the metallic conductors obey Ohm's law? No. All the metallic conductors do not obey the Ohm's law. Few conductors are here, like they are not actually fully conductor or good conductor, they are the semiconductor. Silicon, germanium, other some electrical conductor also like diode, triode, transistor, they do not obey the Ohm's law. They do not obey Ohm's law. So how can we define them? So we can classify them into 2 parts. The conductors, those who obey Ohm's law, and the conductors, those who do not obey the Ohm's law. Those who obey the Ohm's law are called the Ohmic conductor. All generally metallic conductors are Ohmic conductor. So those who do not obey the Ohm's law, they are called non-Ohmic conductor. So Ohmic conductor means they obey Ohm's law. Ohmic conductor, that means obey Ohm's law. Conductors obey Ohm's law. Ohm's law. In general, all the metallic conductors obey Ohm's law. Copper wire, silver wire, aluminium wire, etc. But this is not important for our board exam. But this is very important. Each and every year there is a probability of the question you can see in your question paper, that is non-Ohmic conductor. Non-Ohmic conductor. What are these? Actually, these are the conductors, those who do not obey Ohm's law. Those who do not obey the Ohm's law. Do not obey Ohm's law. Ohm's law. And give example of it. They are the non-Ohmic conductor. Very important. Example. All the semiconductors. Mainly there is a twist. In last few years, it is asked in your question paper that the non-Ohmic conductors are germanium, silicon, MCQ part. In an MCQ question, you see actually these are the semiconductors you see, or germanium, silicon in option. Diode, triode, transistor, they are the non-Ohmic conductor. Similarly, another one important question, related question for the board exam, how can you plot the V and I? the potential difference and the electric current graphically. How can you plot this? The VI graph, simply VI graph or Ohm's law graph or Ohm's law graph. That is very simple. Now I is plotted along the x-axis and V is plotted along the y-axis. When the potential difference 0, no electric current is appear in the circuit. When the potential difference increases, then the electric current also increases. In this graph, you can plot V along x-axis, I along y-axis. There will be no problem. Okay, to get the full marks, 2 marks, if you plot the V along x-axis and I along y-axis, there will be no problem. But for the graphically, if you see that the slope of the graph, that is OA is the graph, now a perpendicular is drawn here. So for this graph, the slope of the graph will be, what will be the slope of the VI graph? Slope of VI graph. Slope of VI graph, this is equal delta y by delta x. Here delta y, that is delta V divided by delta I. This is equal R. R for resistance. R for resistance. This is very important question for your board exam. Again, I just recall you, just knock you. Ohm's law, mathematical forms of Ohm's law, define resistance from Ohm's law, and the ohmic conductor, non-ohmic conductor, only non-ohmic conductor for your board exam, and V versus I graph. In this class, up to this, in the next video, we again go to the another important part for your board exam also. Okay.